Dear students, let's see this problem from wave motion. There is a block M that's hanging vertically at the bottom of a uniform rope. So you can see this is a block and this is a uniform rope. And this is of constant mass per unit length. So it is having a mass, but it's constant. Here, the unit mass. The top end is attached here, and a transverse wave, pulse 1 of wavelength lambda naught is produced at this point, and it takes some time TOA to reach this point. Now, if the same type of wavelength of the pulse is produced at point A without disturbing the position of this point M, then it's going to take time TAO to reach the point O. So which of the following options are correct? And you can see that there are multiple options that are correct. Okay. So the first one which we have to test is whether these two times are equal or no. So we can see that speed is nothing else but distance upon time. Okay. Now, as far as the distance is concerned, whether the pulse 1 is coming from top to bottom or pulse 2 is going from bottom to top, that is going to remain constant. Okay. Now, if you look at this time is this TAO and TOA. That is going to be the time. And now we'll have to look at velocity. Velocity is going to be root of T by mu. That's basically the velocity of a transverse wave that is developed in a string. Now this mass per unit length, that is constant. As far as tension is concerned, that is not constant. But if you look at the trending at the top, this mass of this entire string is going to cause the tension of this point at the top. Okay, and as you go down, the tension will decrease, 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 and so on. So if you look at the variation of tension coming from top to down or from down to top, so it is going to be same. So even though tension is not a constant, okay, but the variation of the tension is constant. And therefore, whether the pulse is coming from O to A or A to O, it is going to be having no effect on this velocity. So that velocity, average velocity, because velocity is not constant at every point, that average velocity will be same. And therefore, we can say that TOA is equal to TAO. So that is option A. As far as the second one is concerned, we can see that the wavelength of the pulse becomes longer when it reaches A. Okay. Now, again, if you look at this one, V equal to F lambda. Okay. Now, the frequency, of course, is going to remain constant because we know that in a medium, as you go from one medium to another or in a single medium, frequency never changes. And this velocity is root of T by mu. This is constant. As far as tension is concerned, I've already explained that tension is going to decrease from O to A. And why does it decrease? Because you can see that as you go down here, below this point A, there is only mass M that is pulling. But for point O, the entire rope is pulling, plus this M is also pulling. Therefore, tension is decreasing when you come to A. So this tension is going to decrease. So wavelength is going to decrease. So it is not possible that it will become longer. So this is false. Okay, so this is correct. This is false. Now, for the C point here, the velocity of any pulse is independent of the frequency and wavelength. So let us not confuse this formula and think that V equal to F lambda. So how can you say it is independent? Don't look at this equation. The velocity actually depends on the tension and the mass per unit length. This is what we have derived for transverse waves developed in a string. So in that sense, it is independent of the frequency and wavelength. So therefore, this statement is true. And then finally, you can see that the velocities of the pulses are same at the midpoint. That's what they're saying. So at the midpoint, you can see here that tension will be constant. So this pulse coming from top to bottom or from bottom to top will experience the same tension at this point. Okay, V equal to F lambda, frequency will be same whether you come from top to bottom or down to top. And because the tension is constant, okay, at the midpoint, whether I go from top to bottom or bottom to top, therefore this statement is also true. that the velocity at the midpoint is going to be same. Okay. So hope that this discussion has answered your question. Thank you so much for watching.